Hi, welcome back. And today we're diving into the subject of how to get the most out of coding with AI assistance, or vibe coding as it's called. If you have been watching my previous videos, then you would know I'm a big fan of vibe coding and I thoroughly recommend it, whether you're an independent software engineer or working as part of a team in an organization. I used to use Cursor as my AI coding assistant. One of the great things about Cursor is it allows you to choose which LLM to use. Sometimes I would use one from OpenAI, one of those GPTs, or perhaps Claude Sonnet 3.5 or even Gemini 2.5 Pro at times. Then Anthropic came out with Claude Code with Opus 4, and I started to use that because Cursor didn't provide access to Opus 4. I think it's basically because it's very expensive. Now, GPT-5 has been released and it's immediately available in Cursor. So if I want to use it, I need to go back to using Cursor. But why do I jump around between models? Because I hear one model is better than another, and so I want to see for myself. I'm hearing many different opinions though. Some say Claude is best, others that OpenAI is best, or Gemini or whatever. And just this morning, I read a blog post saying Grok was the clear winner. Well, it's not clear to me which model is best. And the battle of these models is going to continue and probably drive us all mad, no doubt. I also hear different opinions from software developers regarding their experiences with AI coding assistants like GitHub Copilot, Claude Code, or Cursor, to name just three, and there are many of them. It's getting very complicated and confusing. This is all going to continue. New models will be released, some even open source like GPT OSS. And there will be new AI coding assistants and consolidation between the existing ones. It's going to go on for quite a while, probably years before all this settles down. In the meantime, I've been investigating how, as software developers, we should be working with AI coding assistants to get the most out of them, whatever coding assistant or LLM you decide to use. I'm going to explain a technique you should follow as you bounce around between different coding assistants and LLMs, because this technique is totally agnostic to the particular coding assistant and LLM. And so while OpenAI, Anthropic, Google, XAI, and whoever fights it out, we're still able to maximize our productivity with these tools. The first thing I want you to be aware of is that Markdown documents are the secret sauce for working with AI coding assistants. So we need to have a thorough understanding about them. But why Markdown? Well, I don't know if you've ever tried to get one of the LMs to create Word documents, for example, but it usually doesn't end well. For me, the only one that would even try is ChatGPT, and the formatting was pretty terrible. Instead, LLMs work best with Markdown documents. For those of us that are not so familiar with Markdown documents, let me give you a brief overview. If you are familiar with them, then pop the kettle on and make yourself a nice cup of tea. So, a Markdown document is a plain text file written in something called Markdown, a lightweight markup language designed for easy formatting and was created by John Gruber in 2004. So you can see it's not new. It uses simple syntax like asterisks for emphasis, italics or bold, hashtags for headings, and dashes for lists to structure the document without complex code. It's simple but very effective because it's a plain text document without any fancy formatting coded into the document itself. LLMs find it very easy to both read and write Markdown documents. LLMs also understand the formatting of Markdown documents, so they understand when you are emphasizing text with asterisks or structuring it with sections and headings. So let me show you a great tool called Typora, which you can use to create Markdown documents. Here's a document I created. Actually, I got Claude to create it for me. That shows many examples of the formatting of a Markdown document. Now, this is actually the kind of human view of the Markdown document. So it's kind of like nicely formatted, but actually if I push command / in Typora, it shows you the actual Markdown language. So you can see these hashes here, which are headings. So if I go back to what the view is, so you've got kind of the human view and the kind of, I guess, the LLM view, you could say. So you see these 1 hash is a heading, 2 hashes a subheading, 3 hashes is a subheading, and so forth. And you can see how it looks here. Then you have text formatting. So you can have bold text, and you can see here that bold text is ***, but 1 star is italic text, as you can see here. You can bold and italics, which is 3 stars, and you can strike through with this tilde, and then tilde at the end, and that gives you strike through. You can also have lists. You can just have like bullet lists, as you see here. Now, bullet lists you just create with dashes, dash, and you can have nested ones if you put tabs in there as well. You can also have ordered lists. You just put numbers, and it will create you nice ordered lists, as you can see here. You can have task lists where you can have completed tasks ticked off and incompleted tasks not. And again, it's very simple formatting. Let me show you as we go down here. All you have to do is you put a dash to say it's a list, and you put this open square brackets. And if it's completed, you put an X. If it's not, you just leave it blank. And so you can do it like this. Now, there's lots of other formattings that I'm not going to go into it at the moment, but you can actually create quite nice documents, as you can put code in there. You can have tables and the like and more. Or you can have these horizontal rules. You can see lots of them here. And so you can actually break the text up. So you can see it's quite nice. Okay, so because Markdown documents are just plain text documents, we can also leverage version control systems like GitHub. In some ways, Markdown documents are therefore like software code, easily created, read, and edited like any other software language files, and then version controlled. We will come back to this theme later in the video. The next point I want to cover is that when working with AI coding assistants, it's instructive to think in terms of a coding session. Now, why should we do that? Well, I don't know if you've noticed, but LLMs have no memory. Every session is like starting anew. The LLM doesn't have any context with what happened previously. Let's say you get Claude Code to build you an app. If you come back later and start a new chat session and ask it to continue where you left off, it won't have any memory of what you said to it previously. It won't even know that it actually wrote the app for you. However, there are ways to mitigate this, that you can get back into coding quickly, and understanding the concepts of a coding session can really help. So an AI coding session is where a developer working with an AI coding assistant, and it doesn't matter which one, could be GitHub Copilot, Cursor, Claude Code, etc., makes a change to the code base while implementing either a new feature or fixing a bug. The coding session can last for less than an hour to several hours or even multiple days. At the start of the coding session, the human developer needs to make their intentions clear to the AI developer, basically the goal of the session. They do this with a Markdown document. Now, the great thing is the human developer doesn't even need to write this document. The AI developer can do it because, as we learned previously, LLMs are great at reading and writing Markdown documents. The document is initially created using a prompt, as you would expect, and the prompt can also include the contents of the user story you want to implement. Perhaps you're using Jira or something similar, and you can include any acceptance criteria. By the way, as a side note, I've noticed that when people are typing prompts to their LLMs, they are often quite short. However, LLMs can accept very long prompts, and sometimes the longer the prompt, the better, as the LLM can give better responses the more it knows. Let me segue quickly into context windows. A context window is the amount of data that can be sent to and returned from an LLM. And with context windows, size is measured in tokens. But what is a token, I hear you say? Well, you can think of a token as part of a word. On average, a token is about 3/4 of a word in English. Now, the size of a context window varies quite a bit depending on which LLM you are using, from around 200,000 tokens to 1 million or more. What this means is that your prompt can contain many thousands of words, and it will be fine for the LLM. So, by all means, get into the habit of writing long and detailed prompts to get the most out of LLMs. You don't need to use the AI coding assistant to create the Markdown document. It's entirely up to you. I usually use Claude's app that runs on my Mac to create the document. After the first version of the Markdown document has been created, you must carefully read it to ensure it covers everything that needs to be done, both from a functional and from a technical perspective. Remember that product owners or business analysts might not cover the details of the technical aspects of the feature being implemented in their user story or how the feature fits into the existing architecture. This document isn't just used by the LLM to implement the feature and then thrown away or stored in an archive when it's never read again. No, this document gets committed to GitHub with the rest of the code. It becomes a permanent record of the change for consumption by future LLMs. It sits with the code, and that's where you want it, because we want to think about it as a computer code written in natural language, which is the language of the LLM uses to create computer code. I hope that makes sense. Right, so we now have a Markdown document describing in some detail the feature to be implemented, which not only provides input and direction to the LLM, who will be writing the code, but will form part of the documentation of the system. Let's call this document the Product Requirements Document, or PRD for short. We also need a second document, which is like a mini implementation plan for the LLM to follow. It includes a task list of items that need to be done, tasks that can be marked as completed as we progress through the coding session. Remember how these task lists were part of the Markdown? A temporary document used by the AI coding assistant to keep track of what's done and what still needs doing as it progresses through the coding session. It's important that you get the AI coding assistant you are using to write this document based on the PRD that was created previously. Again, it's important that you carefully review this document to ensure it makes sense. You can tell from this document whether the AI developer fully understands what it needs to do and how it intends to do it. If anything in this mini plan needs changing, then ask the LM to make the changes. Don't make the changes yourself. So these two documents, along with the other documents that describe the application's features, design principles, and coding guidelines, can now be provided to the AI coding assistant to start the coding. After each task has been completed, get the AI coding assistant to commit the changes to the GitHub repository or whatever is being used, even if the feature hasn't been fully implemented. We need the code in the repo where it's safe and secure and where others can access it if needed. This is also the basis for CI, or continuous integration, where the code base is always buildable and can be deployed to production. If you aren't using feature flags, then I strongly suggest you consider using them. There needs to be some distance between the version of the software in production and the features available. In a sense, I should be able to release code without releasing features. Committing code to GitHub after each task has been completed successfully, meaning the code can still be built and the application can still run, even if the feature hasn't been fully implemented, is very important. You see, these AI coding assistants can sometimes do stupid things and make changes that they shouldn't as they descend into an endless rabbit hole or go into a recursive loop. This can end up with a broken application, and frankly, the best way to resolve things is simply to start again by rolling back the changes by reverting back to the state committed to GitHub. Finally, get the AI assistant to mark the task as completed in our mini implementation plan so it knows what has been done and what still needs to be done. Don't end your working day with a task partially finished. No, always finish your day with any change files committed to GitHub and your task list updated. This provides a clean start for the AI coding assistant the following working day. Remember, if you start a new chat session the next day, which you should do, then it won't know where things stand with the implementation of the new feature if it hasn't been documented. When the feature has been fully implemented or the bug fixed, all the tasks in the Markdown document should be marked off as completed and the code committed to GitHub. Of course, you have fully tested the change and the branch you're working on probably needs merging, but I don't think we need to go into any of those details because they aren't specific to working with an AI coding assistant. The task list document is no longer needed and can be deleted as we have no further use for it. Well, that's it. Your roadmap to vibe coding like a pro. Try this Markdown workflow with your favorite AI assistant and let me know how it goes. Don't forget to like and subscribe for more coding tips.